Before we will start our class today, I'm requesting everyone to please rise and let's have our prayer. So requesting the prayer leader to come here in front and lead us in prayer. So good morning, students. How are you today? So you're fine. So before you will take your seat, kindly pick up the pieces of papers and arrange your chairs. Okay. So where is our class beetle? Yes, class beetle, I am requesting you to please check the attendance and give it to me later. Okay? So also before I forgot, kindly pass your assignment in front. Okay. So now, before we will start our proper discussion, I am requesting everyone to please read the house rules in order for us to have our class in organized manner. Okay. Okay, since you're done reading our house rules, did you understand? Okay. Since we're already done with our house rules, now let's proceed to the recalling of our last topic. So, who among you here can recall what was our last topic? Yes, Miss Bainasa. Okay, very good, Miss Bainasa. So, our last topic is all about the improper integrals of one infinite limit of integration, and that is lower limit. So now, who among you here can tell me how to solve the improper integrals of one infinite limit of integration? Yes, Mr. Egot. Okay, very good, Mr. Egot. Also, okay, since we are dealing with limits, so we are interested in the convergence and divergence of the improper integrals. So, how can you say that that limit is convergence or divergence? Okay, Miss Kana. Very good, Miss Kana. So that's it for our recalling of our past discussion. So before we will start our proper discussion, let's have a short game. So I will be showing you a flashcards or a cards. Inside of the flashcards is written in there is rumbled letters, and you have to arrange it in order for you to get what will be our lesson for today. Did you understand? Okay, so my direction is that for you to answer, if you want to answer, kindly raise your hands and make a sound of any animals and state your answer. Did you understand? Okay, very good. For our first bird, I have here. Okay, who wants to answer? Yes, Miss Joanne. Very good, Miss Joanne. So the word is evaluate. Very good. So for our second word, we have. Yes, Mr. Gablinas. What is our second word? Very good, Mr. Gablinas. It is improper. So next, we have this word. Yes, Mr. Apostol. Okay, you are correct, and that is integrals with. For our fourth word, we have. Yes, Miss David, brother. Okay, very good. That is infinite upper. And for our last word, we have. Yes, Miss Nancy. That is correct. We have and lower limits. So for now, since you already got our answer, okay, who among you here can tell me what is our topic for today? Yes, is all about evaluating improper integrals with infinite upper and lower limits. So before we will start our discussion, I have here the objectives. Can you read, everyone? Okay, thank you for reading. For today's session, the learning objective is at the end of the lesson, the students are expected to distinguish whether the improper integrals are convergence or divergence. Next, evaluate improper integrals with infinite upper and lower limits. And the last objective is demonstrate a step-by-step process of solving improper integrals with infinite upper and lower limits. So before I will discuss to you our topic, we have first an activity. This activity has a connection with our previous topic that is about improper integral with one infinite limit. We already discussed about the improper integral with infinite upper and lower limits. The class will be divided into two groups, and each group should provide or should search about the improper integral with infinite upper and lower limits and should provide a sample problem to it. After you create your problem, you need to present it in front of the class. And the purpose of the presentation is for you to gather ideas and to know the concept or to understand the concept about the topic. Did you understand, class? Okay, so let's start to count off at the back. Okay, so now go to your groups and your 20 minutes start now. Your 20 minutes is up, and now requesting the representative of Group 1 kindly come here in front and discuss your problem and explain your solution to the class. Very good, Group 1. Thank you for that presentation, and we will check it later. Next, the representative of Group 2. Good job, Group 2. I guess you already know about topic very well.
Okay, class. So based on your activity, what have you learned? Yes, Miranda? Absolutely, you're correct. So for us to evaluate the improper integrals with infinite upper limit and lower limits, so we must first learn about the improper integrals with one infinite limit of integration. So, what does the improper integrals with one infinite limits of integration? It's important in solving improper integrals with infinite upper and lower limits. Yes, Miss Helen. Okay, you're correct. So, Miss Helen's idea is correct. So, in order to evaluate the improper integrals with infinite upper and lower limits, so we need to express as a limit of two integrals. So, breaking down the improper integrals into two improper integrals with one infinite limit. So, we have this equation. So, the integral of upper limit or the positive limit to negative limit f of x dx is equal to the limit of integrals of 0 to a. So, with a approaches to negative 8, f of x plus the limit of b to 0, so b is approaches to positive 8, so f of x dx. So looking in the equation, so we need to use the one infinite limits upper and the lower limits. So, okay, who among you here the idea of what are the steps in evaluating the improper integrals with infinite upper limit and lower limit? Yes, Miss Asgal. Thank you, Miss Asgal. So Miss Asgal is correct. So the step of evaluating the improper integrals and lower integrals with upper limit and lower limits are, these are the steps of the improper integrals. So first is split the integrals. So break the integrals into two parts, so each with the infinite limit. So we use this formula. The second is evaluate each part. So evaluate each part and separately using the standard techniques for divided integrals. And then the third one is check the convergence each part. So ensure that each part is converged. If one or both parts diverge, so the entire integrals diverges. Who knows the graph of proper integrals with infinite upper limit and lower limit? Okay, Miss Bugon. So please draw it in the board. Thank you, Miss Bugon. So class, as you can see here, this is the graph of improper integrals and infinite upper limit and lower limits. As you can see, there are the left and right region. So that's why we can extend 2 up to positive infinity down to negative infinities. So class, let's solve and check the example of group 1. Okay, number 1. The integral of positive infinity to negative infinity of x e raised to the power of negative x squared dx. So these are the formula of improper integrals. So integrals of positive infinity to negative infinity as of x is e raised to the power of x squared dx is equal to 0 approaches to negative infinity x e raised to the power of x squared dx plus the integral of positive infinity to 0 x e raised to the power of negative x squared. We need to separate the positive and negative infinity. So in negative infinity, the limit of integral of 0 to t is approaches to negative infinity, x e raised to the power of negative x squared dx. So in next step, they use the u substitution. So here's the answer. So limit of the quantity of negative 1/2 e raised to the power of x squared is approaches to 0 to t. So t is our negative infinity. As you can see here, the limit of the quantity of negative 1/2 plus 1/2 e raised to the power of negative t squared. So you need to substitute t to negative infinity. So if you substitute the t to negative infinity, so the answer is 0. So our remaining value is negative 1/2. So in next step, the infinity of a to 0, x e raised to the power of x squared dx is the limit of t to 0. T is approaches to positive infinity of x e raised to the power of dx. So the limit of negative 1/2 e to raised to the power of x squared. So here they use the u substitution. So they cancel x. So the answer is 1/2 e raised to the power of x squared. So next is to substitute the t to the given equation or the given expression. The limit of negative 1/2 e raised to the power of t squared plus 1/2. So you need to substitute t to positive infinity. As you can see here, so the answer is 1/2. So in a given value, so if you substitute positive infinity, so the answer is 0. So the remaining value is 1/2. And the next step, you need to sum up everything, the lower and the upper limit. So is equal to 0 to negative infinity x e raised to the power of x squared dx plus infinity of integral of positive infinity to 0 x e raised to the power of x squared dx is equal to negative 1/2 plus 1/2 is equal to 0. So these integrals or upper integrals is convergent. Okay class, it's your turn now. So please solve this the following problem. Okay class, you may now start. Are you done solving? Okay, I will give you 5 minutes to answer. Okay, time is up. Who wants to solve this given to the board? Okay, Mr. Damiano, please solve it and explain. Thank you, Mr. Damiano. So, did you come up with the same answer, class? Okay, let's check. So, in lower limit, we have this in this equation. So, the limit of a to 0, so a is approaches to negative 8 of 3x over 3x squared plus 2 raised to the power of dx plus the limit of 0 to b is approaches to positive infinity of 3x over 3x squared plus 2 raised to the power of 3 dx. So next step, they use u substitution. So our u there is 3x squared plus 2. So du is equal to 6x. So you need to derive 3x squared plus 2. So our du is 6x dx. So in order to find dx, so you need to cancel 6x in both sides. So 6x over 6x, so you need to cancel out. So the remaining value is dx is equal to du over 6x. And then the next step, you need to replace 3x squared plus 2 to u. So 3x over the quantity of u is the power of 3. So du over 6. So you need to cancel out 3 over 6. So the answer is 1/2. So 1 over 2 u raised to the power of 3 du. Next, you need to separate the constant. So you need to integrate u to raised to the power of negative 3. So next is u raised to the power of negative 3 plus 1 over negative 3 plus 1. So next is the answer is 1/2 over the integral of u raised to the power of negative u over negative 2. So next step is you need to multiply 2 and negative 2. So the answer is 4. And then you need to reciprocal the negative negative exponent to become positive exponent. So the answer is negative 1 over 4 times 1 over u raised to the power of 2. So you need to multiply this value. So the answer is negative 1/4 u squared. And then our u there, so you need to replace u with the use in the u substitution. So our u there is 3x squared plus 2. So 1 over 4, the quantity of 3x squared plus 2 raised to the power of 2, the integral of a to b. So next step, you need to integrate the upper limit and the lower limit. So you need to separate, you need to use this formula. So 1 over 4, so you need to replace x to 0. So 3, the quantity of 0 squared plus 2 raised to the power of 2. So minus the negative 1 over 4, 3, then you need to replace x to a. So 3a raised to the power of 2 plus 2 squared. So 3 times 0 is 0 plus 2, so is 2. So 2 times 2 is 4, so 4 times 4 is negative. So the answer is negative 1 over 16 plus 1 over 4, the quantity of 3a squared plus 2 raised to the power of 2. So these are our lower limits. Now let's proceed to the upper limit. So these are the following expression. So negative 1 over 4, the quantity of 3x squared plus 2 raised to 2. So the integral of 0 to b. So next step is you need to substitute from b and 0. So is equal to 1 over 4, 3, since our x is b squared plus 2 raised to the power of 2, minus negative 1 over 4, 3, so our x is 0 squared plus 2 raised to the power of 2. So these are the value of the upper limit. So negative 1 over 4, the quantity of 3b squared plus 2 raised to 2 plus 1 over 16. So next step, we need to sum up the upper limit and the lower limit. So the limit of the quantity of negative 1 over 16 plus 1 over 4, 3a squared plus 2 raised to the power of 2, 8 approaches to negative infinity, plus the limit of negative 1 over 4, 3b squared plus 2 raised to the power of 2 plus 16, b is approaches to positive infinity. So next step, we need to substitute a and b to the given expression. And then next is the limit of negative 1 over 16 approaches to negative infinity, plus the limit of 1 over 4, 3a squared plus 2 raised to 2, a approaches to negative infinity, plus the limit of 1 over 4, 3b squared plus 2 raised to the power of 2, b is approaches to positive infinity, plus the limit of 1 over 16, b approaches to positive infinity. So you need to copy negative 1 over 16. So next is the limit of negative 1 over 4, the quantity of 3a squared plus 2 raised to the power of 2, a approaches to negative 8. So you need to replace a to negative infinity. So the greater value, it becomes 0. So our answer is 0. Next, plus the limit of negative 1 over 4, 3b squared plus 2 raised to the power of 2. So you need to replace b to positive infinity. So if you replace the greater value of the positive infinity, so the more it becomes 0. So the answer is 0. So next is you need to copy 1 over 16. So next, negative 1 over 16 plus 0 plus 1 over 16. So the answer is 0. So therefore, this improper tables is convergent. So the answer of Mr. Damiano is correct.
You already know how to solve the improper integrals with upper and lower limits. So now, we will be having our group activity. So, the class will be divided into 2 groups. Each group will be given a problem and your task is to solve it. You will be given 15 minutes to solve the problem and you must write it in a manila paper that will be provided. After you write it, you have to make a yell and praise your work in front. So, what do you want? You want the same group or we will regroup? So, before we will have our activity, first we will discuss the rubrics for you to be guided. So, we have here the criteria and its equivalent points. So we have here the accuracy, 10 points, presentation, 5 points, neatness, 5 points, cooperation, 5 points, timeliness, 5 points, total of 30 points. Okay, leaders, please come in front and get your questions and Manila paper. And you may now start your activity. Okay, your 15 minutes is done. So since you're already done with your activity, kindly pose it in front and group 1, present your work. Very good, group 1. Okay, now let's check your answer. So your problem is the integral of upper limit of positive infinity and lower limit of negative infinity sine x dx. So the first thing you did is you use the formula. We have the formula of the integral of positive infinity, upper limit, and negative infinity, lower limit, fx dx is equal to lim from a to 0 fx dx, a approaches to negative infinity, plus lim from 0 to b fx dx, b approaches to positive infinity. So the first thing you did is you substitute fx dx to the given. So we have lim from a to 0 sine x dx, which a approaches to negative infinity, plus lim from 0 to b sine x dx, which b approaches to positive infinity. So now let's get this indefinite integral. So we have integral of a from a to 0 sine x dx. So this one, we will solve this one first. Okay, so the integral of sine x dx, we have negative cos x evaluated by a from a to 0. So we have negative cos x 0 plus cos a. So we have negative cos 0, we have negative 1 plus cos a. So next we will solve this b of 0 from b. So we have 0 from b sine x dx. So evaluated from negative cos x 0 from b. So we have negative cos b plus negative cos 0. And then copy the negative cos b, negative cos 0 is 1. So after we solve these two limits, we will add this 2. So we have lim negative 1 plus cos a, which is from here, plus lim negative cos b plus 1, which is from here. And then, which is a is approaches to negative infinity and b is approaches to positive infinity. After we will have this, let's distribute the limit. So we have lim times negative 1 plus lim minus cos a plus lim negative cos b plus lim minus 1, which is a approaches to negative infinity and b is approaches to positive infinity. Okay, so from this one, we have lim times negative 1. So since lim times negative 1 is considered as 1, and then we will put 1 here and here. So this, we will solve this lim minus cos a and lim minus cos b. So since this is infinite integral, we cannot define what is the real or what is the exact number of it. So we will use the negative 1 to 1 and also here. So we will use negative 1 to 1. So the answer is 1 plus the quantity of negative 1 to 1 plus the quantity of negative 1 to 1 plus 1. So since it is infinite, this problem is divergence. We cannot identify what is the exact answer, what is the exact number of lim minus cos b or lim minus cos a. Okay, now let's proceed to group 2. Okay, good job group 2. Now let's check your answer. So your problem is the integral of upper limit of infinity and lower limit of negative infinity x dx. So again, we will use the formula. And then after you put the formula, after using the formula, we will have this substitution of fx dx. So we have lim from lim 0 to b, from b to c, from 0 to b, x dx, which is a is approaches to negative infinity and b is approaches to positive infinity. So now we will have this, we will get this given problem with the integral of x dx. So first thing that you did is you integrate it. So we have here the integral of x 1 plus 1 all over 1 plus 1 dx. So now let's add the exponent and the denominator. So we have the integral of x squared over 2 dx. So now let's distribute the limit. So we have limit x squared all over 2 from a to 0 plus limit x squared all over 2 from 0 to b, which is a is approaches to negative infinity and b is approaches to positive infinity. So now let's evaluate or let's substitute 0 from x to the upper limit 0. So we have lim times the quantity of 0 squared all over 2 minus a squared all over 2, which is a approaches to negative infinity plus lim b squared all over 2 minus 0 squared over 2, which is b approaches to positive infinity. So now we will have this one. So since our a is our negative infinity, so let's substitute a to negative infinity. And then here our a is the positive infinity, so let's substitute a to the positive infinity. So we have now the 0 minus positive infinity plus 0 plus positive infinity. So now disregard the 0, we will remain the negative infinity plus positive infinity, which is the answer. This problem is divergent. So very good group 1 and group 2. Congratulations, all your answers are correct. Do you have any questions, clarifications, or violent reactions? Okay, so I guess that will conclude our discussion for today. So before we proceed to our evaluation, we will get this first. Okay. So now for us to know if you understand our discussion, we will have our quiz. So get one motion of paper and answer the following problems. So for the direction of our evaluation, we have evaluate the improper integrals with infinite upper and lower limits and identify if it's divergent or convergent. After identifying, show a step-by-step process on how you solve the given problem. So good luck everyone, do your best. Okay, your time is up now. So can you pass your papers in front silently? Okay, so that's the end of our discussion today. And goodbye